Okay, hello everybody. So 5.02 exponent laws consolidation. Let's just get right into it so you don't have to listen to me for too long here. So the first questions here, it's asking us to, without using a calculator, determine the value of blank. So looking at the first problem, we have 25 to the power of 3/5, and that is being divided by 5, the fifth root of 5. So without using a calculator, right, what that means is we want you to use exponent laws, all right? So use the exponent properties, the exponent laws. And all of the exponent laws, if you go back to the previous lesson, they all required the same base. So if we look at this first problem here, we have a 5 here and a 25 here. Those are not the same bases. So we need the same base. Same base. And again, just like a quick recap, like when I say base, it's the thing that the exponents are being, like the bottom of the exponent, right? So you have x to the power of n, and that'd be multiplying by x to the m. So like your base in this case is x. And if those are the same, that's when you can use your laws. So in this case, you'd be adding exponents, right? So always be on the lookout for this. If you can clean this up, well, 25 is the same thing as me saying 5 squared. So if I was to reduce this, or clean it up a bit, this would be 5 squared, all to the 3/5, all, and on the bottom here, we have fifth root of 5, so remember that's 5, and think of your roots as fractions, so this is being the 1/5 up top. So now look, we have same bases, right? 5 and 5. So we can use our rules. So first rule, let's clean up the top. So 3/5 times that 2. So that becomes 5, and 2 times 3/5 is 6/5. And on the bottom, we have 5/1/5. So that reduces to 6/5, subtract 1/5, which you get 5 to the 5/5, which 5 divided by 5 is 1. So you get 5 to the 1, or 5. So without a calculator, just using your rules, try to do the next one, okay? And at any point, just pause the video and just try it out for yourself. And so see if you, and then you can fast forward me, put me on 2 times speed, and see if you can get the right answer. All right. So number 2, we have 3 squared, and on the outside of the brackets, that is put to the power of 3, and then that's put to the power of 0, and that's put to the power of -1. So essentially you have a bunch of power to the power, right? So you start from the inside. So we start with the 3 squared, and that is being put to the power of 3. So that would be like me saying 3 to the power of 2, and then because it's being put to the power of 3, you now multiply that, right? So essentially like this these things right here, they clean up to this. And then that would be put to the power of 0. And then on the far outside, you have that all being put to the power of -1. Well, do that again. So you take 0 and you multiply that. So you get 3 times the power of 2 times 3 times 0. And then you do that one more time. I know some, because you might see it, that there's a 0 in there. It's kind of simplifies pretty early, but I'll just show the full thing. And then -1 here. So then if we take that -1 and we multiply it, you get your final thing as being 3 to the 2 times 3 times 0 times -1. Notice how I put the negative in the brackets. All of this, because there's that 0 in there, that simplifies to 0. So 3 to the 0 is 1. So all of that simplifies to 1. Question number 3, very similar to question number 2, just with one extra step. You need to start seeing roots as fractions. So these are all square roots. So this is the same thing as me saying, I have 3 roots there, so that would be like me having 3 brackets where I'm putting x to the 8 to the power of 1/2. That satisfies that root. And then if I do it again for the middle one there, that'd be like me taking this and putting that to the power of half. And then I would take all of that, and I would do it one more time, and I'd put all of that to the half. Well, now you have something that looks very similar to what we just did right over here, where we're just taking x to the 8, and we are putting it to the power of 1/2, then to the power of 1/2, then to the power of 1/2. So it's like x to the 8 times 1/2 times 1/2 times 1/2. And if we reduce all that, that is x8 times 1/8, which reduces to x to the 1, or x. So let's keep going. Simplify each expression. Express answers with positive exponents. All right, so A, we have a bunch of x's being put to different fractional exponents. So we have same bases. So let's just, and they're being multiplied and divided. So let's just use our product and quotient rules. So up top, we have x to the 2/3 added to each other. And then on the bottom, poor communication, x to the 1/3. Well, this is also being subtracted. So we can do this all in one line, where you then can write it as x 2/3 plus 2/3 minus 1/3. Well, x 2/3 plus 2/3, that's 4/3. Take away a third, that would give you 3/3, which reduces to 1. So your final answer is just x again. All right, in B, we have 5x to the 1/2, and that's being put to the power of 2. And then we have 4x inside the bracket, like this is being multiplied. We have 4x to the negative half. Well, because this 2 is on the outside of the bracket, it gets distributed to this half and also this 5 right here. So that bracket gets reduced to 20, or 5, I'll try it out, 5 squared, and then x, and that'd be 1/2 times 2, right? Like that's what that bracket, when you expand that 2 in, becomes. And then this one reduces to 4. Deal with the negative exponent, and that negative exponent is only on the x. Like this 4 technically has an exponent of 1. So that would be like saying 4x to the 1/2. So then, let's reduce this. We have 25x. That is being multiplied by 4 over x to the half. Or, another way to think of it is 100x x to the 1/2, like that. You have like bases here. So you can go 100x, and that has an exponent of 1 here. So 1 minus 1/2. Your final answer is x, 100x to the 1/2. There's a positive exponent, so we're good. That's your final answer. The next one, x being divided by 2x to the 0. Okay, so don't let this 0 confuse you. The rule still applies. You take this 2 and you multiply whatever exponent number is here, just like we did over here where we took the 2 and the half, right? So that is 2 to that times that 0, and 2 times this 2. So this becomes x divided by, well, 2 to the power of 2 is 4, and then x to the 0 times 2 is still x to the 0. Nothing changes there. Well, x to the 0, that is just 1. So you are just left with x over 4. Pretty simple in comparison to the other ones. Much fewer steps. Okay, D. 3xy to the power of 3 divided by 9x4 y4. All right, so now we just have 3, I don't want to call them terms, but 3 variables, numbers. So this 3 gets applied to everything. That 3, this x, and this y. So that 3 becomes 3 to the power of 3, x to the power of 3, and y to the power of 3. And you know what? Just an easy way to see this 9 right here, that's the same thing as saying 3 squared. So it's like on the bottom, 3 squared, x4, y4. Did you need to do this whole 9 into 3 squared to solve this? No, you don't. I'm just getting used to seeing it. Okay, so we have 3 squared on the bottom, and those will cancel out one of these, so you'll be just left with a 3 up top. We have 3 x's up top and 4 on the bottom, so get rid of all these. You're just left with a x on the bottom. And we have 3 y's up top and 4 on the bottom, so get rid of these 3, and you're just left with a y on the bottom. And there's your final answer, 3 over xy. Okay, ooh, this one's a little trickier. We have a negative exponent, but we also, our whole thing is a fraction. So in order to do this, I would really recommend just kind of thinking it similar to what we did when it came to the rationals, right? Where you have this as it's written. You have 2z3 to the power of negative 2, and that's being multiplied, right? I think of it as like your a value from the rationals. That's being multiplied by 1 over w5 z squared. So now we can deal with this negative exponent here, and what that's going to say is, oh, take everything on the inside here and flip it. So that's 1 over 2z3, and that is all put now to the positive exponent of 2, and multiplied by 1 over w5 z squared. So take this 2 and now distribute it in, so it gets distributed to everything. So that would be the same thing as saying 1 squared, which would just be 1. And that's 2 squared, which would be 4. And that's z cubed squared, which would be z3 times 2, so z6. And that's being multiplied by this w5 z2. And the reason I separated like this is now you can see you have two fractions essentially multiplying each other, right? As it stands before, if you were to just look at this problem and flip it, like if you were to say, oh, okay, I see a negative exponent, and I'm going to flip that. That's what Mr. Phillips told me to do. So I'm going to go 1 over 2, 3 squared, and that's all being divided by w5 z2. This might be harder for you to see, right? It might not be as intuitive as to, okay, well, what operation? Like, does this w5 go up here to the 1, or does it multiply this? Like, it's just not as clear. But if we separate this fraction as we've done here, then you can see that eventually you get to this step where, yeah, you end up multiplying denominators. So we get 1 over, and then just cleaning it up, we have 4 w5, and then those z's, they add up, and you get z8. And that's your final answer. Okay. So this one. Well, we have a bunch of x's here, so it's actually not similar to what we did before. It's not the exact same, but actually, let me start it and then I'll show you why it's not exactly the same. So first thing, let's take this 5 and multiply this -4. So we have x to the minus 20, and that's being multiplied by x to the 3, and that's all being divided by 3x to the -1. So you can approach this problem similar to what we did before, where you're like, oh, okay, well, these are all being multiplied, so I'm going to write this as x to the -20 multiplied by x to the 3, divide that by 3x to the -1, right? But in this case, I actually don't think that's as clear as what you could do if you just simply collect all your like bases. So this 3 right here, think of it as like the k value from the rationals. You can factor that out. That'd be like you putting a 1/3 up front, and then you have all of these x's being multiplied and divided. So just simply use your product and quotient rule. Notice how I haven't really changed anything. I just pulled that 1/3 out to make it easy. So now this is the same as me saying 1/3 multiplied, well, follow it. It's minus 20, and then we have 20 multiplying this 3. Like these two are multiplying, so they'll be adding that 3. Adding that 3. And then on the bottom, we are dividing that, so this would be subtracting -1 from this exponent right here. So just keep careful with your negatives, and especially when you're subtracting a negative exponent from the bottom. This is a mistake that I can see a lot of people making, okay? It's so easy just to mess that up. So we have 1/3, I'm going to keep writing in green, 1/3 times, well, x to the minus 20 plus 3, so let me just write this out, plus 3, and then that negative times the -1, well, that's plus 1, so that's 1/3 x, and then that whole thing would be minus 16. So then you get 1/3 times 1 over x to the 16, or you get 1 over 3x 16. Okay. The next problem. So here, just look at all of your like bases, right? And you kind of write one big expression by only looking at your like bases. So go through, do your coefficients, 2, 3. So 2 times 4 times 3. So 2 times 4 is 8, times 3 is 24. And then on the bottom, you solve that 3, and then do all your like bases I just said. So multiplying, and then up top, well, actually we'll just do it all. We have x, 2, so we have underline them in green, so there is your x squared, your x, and then you have this x to the minus 3 here, and then you can see your y's are in blue, blue, and blue. So if we look at the green x underline, we have x squared, and then that is being multiplied by this one right here. So adding then that 2, and then that is being multiplied by this one right here. So you're going to be adding that 1. And then on the bottom, you are dividing by -3, so that means you'd be subtracting by -3. So that deals with all your x's. That all is being multiplied then by y, and it's 4 right here, 4. And then right here, you're multiplying, so adding that 4. And then right down here, we are dividing, not dividing, minus that 2. And there, you've dealt with the fraction that was originally in the problem by just factoring out essentially your coefficients. So those coefficients now, they reduce to 8. And then you have multiplying x. Well, what does all that simplify to? 2 plus 2 is 4, plus 1, 5, and then essentially adding 3, so that's 8. And then y 4 plus 4 is 8, minus 2 is 6, so times y to the 6, or I don't even need those multiples, that's just 8, x 8, y 6. So same thing here, deal with your coefficients, so 2 times 3, so that would be up top, we'd have 6, and on the bottom, pull out your coefficient, 3, and that's being multiplied. And this, I guess the y is our first term, so let's just look at our y's first. So there's our y, there's our y. So we have y3, and then that's being added to another third. And then we also have a 4 down here, so subtract a 4. And then let's talk about our x's. So we have 1x here, so x to the 1. And then we have down here, we have 2, so subtract 2. And did I miss anything? Nope. Oh, equals. So equals 2, and then we have y, and then that's 3 plus 3 is 6, minus 4 is 2, and then we have x to the negative 1. So then proper final answer is we can't have this negative exponent, so your final answer then is y squared, and essentially that x, actually, you know what, I'll just show this step. That x will be 1 over x, which your final answer then would be y squared over x, because you want to deal with the negative exponent. Almost done. Yep, that's the next lesson. Only 3 more to listen to me for. Okay, so 3x squared y squared divided by 2x negative 1, 4x squared y. And again, these properties, everything I'm showing you, by the way, right now, only works because everything is being multiplied or divided, okay? If at any point, like, so for example, let's imagine I rewrote this as 3x squared y squared, and on the bottom, you know, like, let's just imagine this problem is split up with these. So 2x negative 1 plus, and there was a plus there instead of a multiplication, x squared y. Well, at this point right now, you can't use your exponent rules. It's not like you can sit here and be like, oh, okay, well, I'm going to cancel out my y's and my x's because I'm going to be dividing them out. No, because you have this addition here, you can't use your rules, okay? So this only works, like this whole thing works because everything is being multiplied and divided. So rules do not work when multiple terms, right? So that's like kind of what I was saying yesterday, where like as soon as you put a x plus y and you put that into, like you put that squared, right? Like you can't distribute this 2 to both of these. This is not the same thing as saying x squared plus y squared. That's not the same thing, right? Like we know this would be the same as saying x plus y, and you would get x squared plus 2xy plus y squared. So see, fundamentally very different. And why? It's because you have this addition here, okay? So because this is multiplication and because you have this fraction line here, you can use these rules. So just always be on the lookout for that, okay? This mistake is so common. So please don't do it. All right. So just like we were doing before, let's look at our coefficients. So 3, 2, 4, that means up top we'll have a 3, and then we'll have 2 times 4 will give us 8. So that's what we will have. We'll pull that out. And then let's look at our x's. So we have a 2 here, so x squared. And then the next one that we deal with is this negative x1 here. So we'll be, and that's on the bottom of the fraction, so subtracting negative 1. And then here we have x to the 2, and that's also on the bottom, so it's subtracting 2. And then we get to our next variable, which is y. We have 2 up top, and then you see only the 1 on the bottom, minus 1. So let's clean that up. That's 3/8 x. Well, 2 take away -1 is the same as me saying 2 plus 1. So that's 3 minus 2. So I'll write this out. 3 minus 2 times y to the 1 essentially. So 3/8 x y. And whether you leave this fraction like this, you can also write it like this. 3xy over 8. Both are equivalent. I don't have any preference on which way you do it. Okay. J. So we have all of these terms here. All right, not terms, sorry. We have these brackets all being put to the power of 2. Put to the power of 3. Put down here, all of this is put to the power of 2. So there's a few ways you can approach this, right? You can think of this as like, oh, well, I have all these brackets being put to a larger exponent of 2. So I can use my power to a power rule. But remember I was saying, work from the inside outwards, okay? So look at your brackets here and work inwards and then out. So deal with this exponent, and this exponent first. So you still have this big bracket here. We'll deal with this last, okay? So work inside out. Take this 2 and distribute it to everything on the inside. So this first bracket then becomes 4, and then x to the 4, y to the 10, because you've multiplied it by 2. That's being multiplied by 6 to the 3, so 6 to the 3. Actually, I probably need a calculator at this point. That's 36 times 6, so my mental math is not great right now. 216. I should have known that. 216. 216, and then x, so that 3 times that x to the 6, that's x to the 18. And then 3 times the -1, that's y to the -3. And then on the bottom, we do that same thing. Take this 2, multiply that 3, or not multiply, sorry, but put to the power of. Yeah, do not multiply. Do not multiply. So 3 to the power of 2 is 9. 2 x to the 4 put to the power of 2. That's x to the, sorry, why am I writing in purple? That is x to the 8. And then 2y squared put to the power of 2 is y to the 4. Okay, now still working inside the big purple brackets, let's approach this problem as if these brackets weren't here. Like, think of it as like, imagine I just gave you this, right? And then this problem would be identical to the last few that we've done, where it was just like a bunch of mix of variables put to it, right? So yes, these brackets are here. But think of this problem as like the ones we've done before. So let's look at our coefficients. Look at your coefficients. So we have 4 times 16, so I'll write this out. I don't know why I keep swapping colors, but 4 times 216, and that's all being divided by 9. So 4 times 216, and that is being divided by 9. And that's all being multiplied. Now let's look at our variables. So we have the x to the 4. So that's x to the 4. And then here we have x to the 8. And again, these are being multiplied. So that would then be being added, right? And then on the bottom, you have a division of x to the 8. So then you're subtracting 8 x's. And then do the same for your y's. So we have 10 y's up top, this first one right here. And then we are adding -3. So we are adding -3 because those y's are being multiplied up top. And then you're taking away the 4 that are on the bottom. And then don't forget, this whole thing is still being squared here. So I will 100% need a calculator for that coefficient. So 4 times 216, divide that by 9. 96. 96, and then that is being, oh, it's still in a bracket, 96, and then that is x, 4 plus 18 is 22, take away 8, 14, 14 times y, 10 minus 3 is 7, minus 4 is 3, so y cubed, and then, oh, bracket, and that's being squared, and then finally we can deal with this squared, so that goes to 96. So what is 96 squared? 96 times 96. 9,216. 2 times that x to the 14. Well, that's x to the 28. And then 2 times that y to 3. That's y to the 6. And there we go. There is your final answer. Okay. Oh, no, we have one more. Sorry. Well, that is your final answer. But I was about to say that's the end of the video. So, oh, we have one more. Last problem. We have k, and under the square root, we have p to the power 20, q to the power 5, and then we have under the cube root, that's all being multiplied under the cube root, negative 64 p cubed q squared. So, how to approach this? Well, think of this on the inside here as me saying p to the 20, q to the 5, all of this is being put to the power of a fifth and then being squared. Same thing on this one. We have on the inside here minus 64 p q2 all being put to the 1/3. So now you distribute those exponents. So let's deal with the inside first. So 5 going to both of these. So you have on the first bracket p 20 over 5 and q 5 over 5 all being squared. And then here you have minus 64 all being put to the third, p put to the third, and q put to the 2/3 when you multiply this one through. Okay, so then we get p to the 4, q 1, and then we can reduce negative 64 put to the power third is negative 4, p third, q 2/3, and now these are all being multiplied, so we can just add exponents. So we have minus 4 p 4 plus 1/3, and then we have q 1 plus 2/3, with your final answer being negative 4p. Well, 4 plus 1/3 is the same as me saying, what, 13/3? 13/3. And then q, what's that, 3 plus 5/3. There you go. Now we are done. Okay? All right, I will see you all on Monday. Bye for now.